I'm now going to give a brief overview of the MELODIES project as a whole. For those of you in the room who aren't familiar with it already, you'll see many more detailed presentations tomorrow, and you'll have obviously the opportunities to see demos today and tomorrow as well. But I just wanted to give you an overall flavour of how the project fits together. So as Jose Miguel said, we started 3 years ago, November 2013. In case anybody's wondering, the acronym stands for Maximising the Exploitation of Linked Open Data in Enterprise and Science. I was quite pleased with that acronym, and I probably will never coordinate another project again, because I don't think I'll get an acronym to work quite so well as that again. But anyway, it kind of captures the idea that we're looking at exploiting open data in both science and in business. This is how the project consortium is made up. We have 16 partners from 8 European countries, and as Jose Miguel said in his talk, it was very important in this particular call that we had a very strong involvement from SMEs. So in fact, we exceeded the minimum requirement for this in the call, and out of the 16 partners, 9 of these are small and medium-sized enterprises, which we're very pleased with, and all of which will be represented in this meeting today, of course, and tomorrow. The overall concept of the project was quite simply to take different kinds of open data on the left-hand side there and turn those into information through what we call services or applications. We tend to call them services within the project, but these are the applications that an end user would actually use in order to answer a question that he or she might have. So despite what that diagram says, there are actually 8 services in the project, and you'll see more of that later. And in order to help those services develop and to come to some common ground in terms of technology, we have a common technology platform on which those services are based, and that's based around the Teradue cloud platform, which Hervé will be talking about in the next presentation. And also, as well as consuming open data from various sources, we'll also be in many cases producing open data that will feed back into these repositories as well. So just to return to the project objectives, I'm sure many of the project partners they lie awake at night thinking about these 5 objectives that we had at the beginning of the project. But they were simply to combine multiple open data streams to develop innovative services in a broad range of what's called societal benefit areas. And societal benefit areas capture both public and private sector applications. To apply linked data approaches, I'll say quite a lot more about linked data later on, and we'll hear more as the couple of days goes on, to enable multiple sources of data to be integrated, whether they be Earth observation or socioeconomic data or wherever the data might come from. It's very important that we considered from the beginning of the project how the services, these applications, and indeed the technology could be sustainable beyond the end of the project, because we're all well aware of research projects that come to an end, and maybe not all of the outputs live on as well as they could. So we considered that from the start, and we've had an ongoing work package throughout the whole project, looking at factors that might affect the sustainability of the services and encouraging the services developers to develop in such a way that they will continue. To deliver reusable technology for exploiting and processing or visualizing or linking open data that we can use ourselves within the project, but we can also make available to others. And really, I guess the overall message of the project was that if we could demonstrate that we were building really interesting and innovative new applications using open data, that would stimulate data providers to release more open data. If we could show to them that, thanks very much for the open data, guys, we'll do something really nice with it, and please give us some more, then that's what we really want to do with this project. So I'll start with an overview of the MELODIES services, and I'm not going to go into any details, unfortunately, because I don't have time right now, but as the days go on, you'll learn a lot more. So as I mentioned, there were 8 of them, and some of them address particular regulatory or requirements. Some of them look at measuring indicators of, for example, desertification, or looking at greenhouse gas inventories in the UK by looking at land cover changes. Some of them look more at private sector applications. So, for example, in Vista's application, we're looking at providing better information to farmers on how they manage their land from both an economic and an ecological perspective. We're looking at marine transport applications, so how can we ensure that ships arrive at port at the right time and the ports are ready for the ships. That's big business that involves big numbers. Using improved citizen observations of groundwater modeling so that we can improve modeling of groundwater, and more besides. So you'll see these described in more detail around. But the point was that these were very highly diverse applications with very different requirements of what they wanted for open data, and we wanted to use those as challenges to weed out what are the real issues here. And because these services were really wanting to be live services, real operational services at the end of the project or soon after, we thought this was a really good practical test for the technologies and for the principles of open data. We didn't do it the other way around, so we didn't decide we build some technology and then create some simple test cases for the technology. We wanted to turn it around and say we want to build some real services here and then work out what's needed from the technology side. And so each of these services, each of these 8 services had, before the project started, an identified user community and one or more advisors identified from that community. And we had a project advisory board who advised us throughout the project, who's made up of those, not only of those specific users, but also other experts internationally who were interested in this area of open data and cloud computing and big data and all this kind of stuff, who could advise us on what's going on in the wider world out there. And I've compiled a list of our project advisors, and I think there were more besides who supported us in other ways, for example, by providing letters of support. And I'd just like to take this opportunity now to thank our advisors very much indeed for all the advice they've given us throughout the project, and maybe all the project participants could join me in thanking them in the traditional manner. So thank you very much indeed. So I'll move on to talk a little bit about the technology platform, and Hervé will talk about this in much more detail. So Teradoué and their partners around Europe have been working on cloud computing platforms for a number of years through different projects, originally coming from the initiatives through the European Space Agency and GPOD. And the idea behind this was to simplify the job of the service developers in developing their service and scaling it out to larger numbers of users or larger data sources. So they were able to be provided with a sandbox environment that enabled them to privately set up their processing chains, set up their data services on a smaller scale, and then easily scale that out to a larger processing platform when they needed to, or when their data requirements grew, or when their users grew. And the idea was, because we had such a large number of SMEs within the project, not all of whom have access to the sort of data infrastructures that we might have in a university, for example, the idea was it would help them to get started, and I really hope that that's been the case throughout the project, and we'll hear more about that as we go on. Another research theme throughout the project, which has been continuous throughout the whole project, has been this idea of linked data. And linked data is really an area that's not familiar to most people. It's a lot of people will see it as quite a technical area. And what we were trying to do was see if we can use these concepts of linked data and make them come to life in a way that would make diverse data more accessible, more usable by many different kinds of users. So this is the quote that I like to use, which I've slightly adapted from a Tim Berners-Lee quote, which is, "If the web made all the online documents in the world look like a huge book, linked data will do the same for data and make it look like one huge database." So whereas the web that we use every day is basically a collection of documents, a huge collection of documents intended for human reading or human viewing in the case of videos, linked data is about doing the same thing but making the data more machine readable so that data systems can be more intelligent. We can form links between data sets. We can combine data together in a more automated fashion. And so this is an idea that's come originally, I guess, from the computer science community, and what we're trying to do is really apply these ideas in practical applications. Some of you may be familiar with this concept, which is the 5 stars of open data, available in various places on the web, and this gives a kind of hierarchy of different levels of openness, I guess, of data. So you get 1 star for picking a bona fide open license for your data. You get 2 stars for making it available in a machine-readable form as some kind of structured data. You get 3 stars if that structured form is non-proprietary. In other words, you pick something like CSV instead of Microsoft Excel format or something like that. And getting to 3 stars is where, in my experience, a lot of people get to with open data. They're able to publish their data on the web in some non-proprietary form, and that's a great start. Getting to 4 and 5 stars is where linked data really comes in, and it's also where things get more technical. So for 4 stars, you have to create identifiers like lookups for all the things that you care about in your database, so your documents or your data sets or your locations or your sensors or something like that. They should each have an identifier that can be looked up on the web, and that means that other people can point to you. It's like a flag, it's like a signpost that says, if someone's talking about me and my data, this is the thing that they should use. This is the identifier they should use to talk about. It's like a digital object identifier or one of those codes in a library that identifies a book, or an ISBN number, something like that. So you get 4 stars for providing good quality, persistent identifiers for your things. You get 5 stars if you then link to other people's things as well. So then you can start to build up this web of data, as it's called, by building up this network of links. And so this is a diagram that you have to show in a linked data talk, otherwise you lose your linked data license. But this is a snapshot of what's called the linked open data cloud. So this is a lot of data sets that have been published in this way and are linked together, and you're not intended to read it in detail, except maybe to see the central nexus in this is DBpedia, which is like a machine-readable version of Wikipedia. And also the other second biggest bubble in here is the GeoNames database. So this is a database of names for geographic locations and things like that a lot of people link to as their kind of identifiers for things. The orange kind of stripe, I guess, down to the southwest there is geographic data, but you can see that a lot of this is government data, a lot of this is repositories of publications, biomedical data, linguistics data. So it's much wider than Earth observation data, it's much wider than environmental data. So we wanted to publish data that was going to be part of this cloud. And to do this, we've been very fortunate to have in the project our colleagues from the University of Athens, who have developed over a number of years a number of tools for manipulating and producing linked data, particularly geospatial linked data, in other words, linked data that's connected to geography in some way. And they have a suite of tools, which I don't think I have time to go through now, but you'll hear much more about from our colleagues at Athens. Everything from storing and querying geospatial linked data to converting existing data formats like shapefiles into geospatial linked data, taking existing geodatabases and wrapping them in a linked data format to make it easier for people to publish data in this way, or to use tools to discover links between existing data sets. So we looked really to our colleagues in Athens to provide us with the tools to help us manage this complicated area of linked data. Another common theme we had throughout the project was developing web applications and visualizations of data, and we came up with a number of tools from this. So again, from the University of Athens, the Sextant tool is a tool. It's like a WebGIS kind of tool, but specifically for time-evolving geospatial linked data. So you can use this as your front end to your geospatial linked data store. And I think there'll be demonstrations of this over the next days. We have the bottom two are from the University of Reading. We have a web app service implementation compliant with the Open Geospatial Consortium for visualization of large raster data. And we have a new JSON format, for those of you who know what that means, for building richer web applications. The idea is that we want to get open data into the web browser so people can make much more rich web applications that really engage the user and really help the user to process data and understand it live, so to speak. Very important in the project were the cross-cutting activities that went across all these services and all these technology developments. So dissemination was one of them, which is why everyone's here today, of course. I'll just give you a quick summary of our dissemination efforts. So we split down our dissemination kind of categories into talking to the scientific community, industry, civil society, policymakers, or media, and that was our rough breakdown. So I guess if you added all those up, there'd be we'd have some of the events that we had were for more than one audience, of course, but we probably had something like 150 different dissemination events, or which might be one-to-one meetings, they might be conferences, they might be presentations and workshops, that sort of thing, throughout the project. So we put a lot of effort into this, both at the level of individual work packages and talking about the project as a whole. I know this is the dreaded Web Mercator projection. We should be using an equal area projection for this, but let's put that aside for the moment. These are the visitors to our website, which we see we have reasonably good global coverage, even though some of those might only be one visitor, of course. But at least it shows that we were getting out there. We could do better in Lesotho, for example, down there. But we're very pleased to note. I only saw this graph yesterday, actually. Very pleased to note that we do have. Our website has been out there and been visited from numerous countries internationally. One of the most successful parts of our website was our blog, and Bethan did a great job in kind of persuading all the various partners to create blog entries about their different activities within the project. And I don't expect you to read all of those entries there, but some of the blog entries were getting several hundred views here, which I'm really pleased with, and I think we can officially designate Gerardo as the winner here for his blog on the challenges of mapping land cover. Looks like you've got about 450 hits and that, so either Gerardo was sitting there clicking the link one night to get to the top of this graph, or people were really interested in that particular topic. So I'd encourage you, if you haven't seen these already, to go to our blog. These are intended to be articles that are for a more general audience and a bit of an easier introduction to what we're doing as a project at a less technical level. You can see also, I think the one in second place there was about linked open environmental data, pushing 400 hits there. So that's really pleasing to see as a kind of, it's showing that there is a large amount of interest in the community in that field. We've also been involved in some standardization activities with the Open Geospatial Consortium. I've been working with Ed in the context of this joint spatial data on the web working group, which is organized between the Open Geospatial Consortium and the World Wide Web Consortium. We've also been active in the Inspire and the GEOS communities in taking part in their meetings, and there's been some interest from those communities too on how they can adopt some of our technologies as potential future standards. We'll talk a bit more tomorrow morning about questions to do with sustainability of the services, but I just wanted to give an outline this afternoon. So when we started the project, we had 8 very different services. Some of them were starting from zero. Some of them already had an ongoing development that they wanted to enhance or change in some way. Different types of organizations and different success criteria, I guess, for those services. So what did we mean by sustainability in the end? Well, what we really wanted to see from each of the services was some kind of a living outcome. And that might have been full commercial service, but it might also be a new data set or a new capability that might be picked up by our user community. We didn't necessarily say that it has to be operational on the 1st of November after MELODIES finished, but we wanted to see that kind of the path towards adoption, let's say. So the job of this part of the project was how to maximize the probability for all these services to have one of these living outcomes. And so you can imagine the sort of things we were doing for this. So we're trying to engage with users throughout the project. We're trying to identify barriers, both technical and non-technical, looking at the costs and business models, and looking at what the role of the technology platform is in ensuring this sustainability. So just to summarize, I think we have some good news stories here. We surveyed all of our services, and some of them split into kind of 2 separate areas of activity, which is why we use this word sub-service here, because some of them actually went and decided they actually had 2 different kind of products to offer. And so 6 of those were expected to become operational at some level. Almost all of them are planning further or technical business development, and they all have some kind of continuation plan. So nobody is planning just to stop at the end of MELODIES and throw in the towel and abandon what they're doing. Eve will talk about the ongoing business model for the Teradue cloud platform, which is a mixed model of people can come in with their research funds to pay for their time on the platform, or they have a direct subscription model for anybody who wants to pay on a commercial level. we picked out some examples of what we might call the quantifiable benefits from what we've done. This is of course quite hard to pin this down in a rigorous manner, but we have some comments from the partners like because one of the input data sets to what we call Work Package 3 was open, that would have previously incurred a commercial cost of $350,000 in that case. Cloud processing on the platform would have saved tens, maybe even hundreds of thousands of euros on in-house resources. Other EO data costs reduced by tens of thousands. Reducing production time. It's not just necessarily just about the upfront cost, of course, but about the time it takes to get going on a service. And Work Package 7, you'll find out what those numbers mean, believe that they were able to reduce that by a large factor. And of course, there's user benefits here. I'm running out of time, so I'm not going to go through these in detail, but just to pick an example from the Work Package 9, which is about ship routing, the problem of getting ships to their ports in time is an expensive one, and if ships arrive late or even early, it incurs costs for the operators or for the ports. And so if we're able to provide better information, then preventing a single incident could save, the estimate here is 18 to 30,000 euros on a single incident of a ship arriving at the wrong time at port. So some common challenges, which I think can form some talking points later. Understanding that the variety of open licenses can be pretty hard, not only for users but also for producers. The last thing that most people want to do is get legal advice involved in selecting their open license or trying to understand the open license that other people are providing, because that incurs severe delays and costs, of course. So simplifying the landscape of open data licenses would be a really important thing that would help user adoption, I think. There's still a lot of confusion over the means of free and open, and they're not quite the same thing. Open data and free data are not necessarily the same thing. And so it's getting to understand what those differences mean and what you're entitled to do with the data and what the cost actually means can be quite tricky for people. I think one plea from the user community that we find is that publishing open data is not just a question of throwing data over the wall. It's a continuous activity that requires the data to be maintained, updated, maintaining a quality of service, and keeping in touch with the users. And so we see a lot of open data sites, for example, falling by the wayside or not having continuation funding. And so we have this question: where do you put your costs? Where do you put your money? Do you try and release as many data sets as possible, arguably to a lower quality of service, or do you focus on certain data sets and really kind of maintain the user community and maintain your quality of service? We all probably know about the importance of good quality metadata, but it comes up again and again. And ease of use is, of course, a big challenge for lots of people. We know we all really like having this access to the new Sentinel data access streams from the Copernicus satellite suite, but actually getting hold of the data is still quite challenging for some, particularly if all they want is a small amount of data out of a large archive. So I think we can, there's continuous work ongoing to make that easier. And this idea of linked data is a very promising one. Application developers are starting to see the benefits of this, but they also see some costs in that if the data provider has not already made the data available as linked data, it's costly to perform the conversion yourself. So you hope that your data provider has gone to the effort of providing data in this linked data form. But if they've done so, the message we're getting from a lot of the application developers is that that's beneficial. It does help them to build applications, but because it helps the data be very clean, it helps it to be unambiguous and linked to other data sets, but someone's got to bear the cost of doing that conversion. So I think I'll finish there and move on to our guest speakers, but in summary, what we're really trying to do is showing that open data has real benefit for diverse environmental applications. And we're underpinning this with shared technology and a shared platform with linked data as a common research theme throughout the project. So with that, I'll thank you very much indeed for your attention.